Hello everyone, in this video we'll quickly discuss 1 mark questions of section A of physics class 12th board paper of 2020. The series I'm going to discuss is HMJ1, set number 2, code number is 55/1/2. Okay, I'll be uploading different videos for different sets. Section A, moving on to first question. This one is really easy, kind of formula based. Simply, if you know that kinetic energy maximum equals to energy of photons, maximum energy of photons minus the work function, if you know this formula, then this question will be really easy. You just need to find kinetic energy maximum for both of the cases and then divide them. So this is the solution. Answer is 1:3. Question number 2, we have to find the incorrect statement regarding Rutherford's model, and the answer is D. Of course, the stability of atom was established by the model. No, actually it is one of the drawbacks of Rutherford's model, and that's why it is not correct, and answer is D. Question number 3 says the resolving power of a telescope can be increased by increasing. Okay, if you know the formula of resolving power, then the question is really simple. Okay, is the simple definition. If you don't know or haven't read this, resolving power equals to A upon 1.22 lambda. Okay, so that means resolving power is directly proportional to diameter of objective lens. Okay, so answer is B. Okay, question number 4, the magnetic dipole moment of current carrying coil does not depend upon. Okay, simple. We have formula M equals to N times Ia, where N is the number of turns, current is I, and A is the area. So therefore M is independent of material of coil. Okay, magnetic moment is independent of material of coil. So answer is D. Fifth is for a glass prism, the angle of minimum deviation will be smallest for. So to answer this question, we know that red light has the minimum refractive index, and we know that minimum deviation is directly proportional to refractive index. Therefore, red light has the smallest minimum deviation angle. Then question number 6. Oh, free marks. Yeah, there we go. It's a quite common question. Everybody knows the answer, right? You know the answer. It's 1.47, right? I don't need to show you this solution. Okay, moving on to the 7th question. The resistance of metal wire increases with increasing temperature on account of. Okay, so the answer is like this. When temperature increases, the thermal speed of electron increases, which means collisions between electrons and positive metal ions become more frequent, which decreases the relaxation time. Simply, you can remember that relaxation time is inversely proportional to temperature, and temperature is directly proportional to resistivity or resistance. Therefore, it is actually due to decrease in relaxation time. 8th question, an electric dipole placed in a non-uniform electric field can experience non-uniform electric field. Of course, it will always experience both torque and forces. Then question number 5, if net electric flux through a closed surface is 0, yes, charge enclosed is 0. Now here the notable thing is the body may have equal amount of positive and negative charges. Okay, so we cannot conclude from this that there will be no presence of charge will be there, but net charge won't be there. Then question number 10, Kirchhoff first rule by the conservation of charge conservation. Okay, then 11th, here the minimum angle of deviation is equal to the angle of prism, and it is an equilateral glass prism. That means A equals to 60 degree, and that is equal to sigma m. Now you remember this formula of uh, refractive index. Mu is equal to sine A plus sigma m by 2 upon sine of A by 2. Okay, you remember this? So put the value of A and sigma, you'll get U equals to under root of 3. Okay, then Bohr. According to Bohr atomic model, the circumference of is an integral multiple. Man, it's really common, really pretty easy question. Beta decay. Okay, mass number is same. Mass number is always same. Okay, Moving on to question number 13. If the number of turns of solenoid are double, we need to find the effect on self-inductance. So we know the formula of self-inductance, that is mu naught n square pi r square into L. That is, self-inductance is directly proportional to the square of the number of turns. Therefore, if the number of turns are doubled, then coefficient of self-induction will increase by 4 times. Then question number 14, laminated iron sheets are used to minimize eddy currents. Okay, they are used to minimize eddy currents. Then 15, magnetic field lines are repelled by diamagnetic substances. Okay. 16, why cannot we use silicon and germanium in fabrication of visible LED? Because silicon and germanium are not suitable, as those junctions produce heat and no appreciable IR or visible light. They produce very little amount of light, and that too in infrared region, which is not useful for us. Question number 17, variation of stopping potential with frequency is given for two different metals. We need to find out which one has greater value of work function. Now, according to Einstein's photoelectric equation, we establish a relation between stopping potential and frequency of photons. On comparing this equation with a straight line graph, y equals to mx plus c, where the c, that is the constant term, or the y-intercept, is minus phi by e. E is constant, that means the work function is directly proportional, okay, to the negative intercept of y-axis. You will find out that m2 has higher intercept, therefore it has greater work function. Then 18, increasing doping concentration and width of depletion layer. When you increase the doping concentration, depletion layer width will decrease. Then moving on to 19th, okay, nuclear radius of aluminium with atomic mass 27 is 3.6 Fermi. We need to find out the nuclear radius of copper. So here is the answer. Nuclear radius, we know the formula, that R is directly proportional to A raised to 1 by 3. If we remove the proportionality sign, we get a constant R naught. Now we'll find out that R naught, because this radius is given, this atomic mass is given, and we'll find out the R naught, and that comes out to be 1.2 Fermi. We get R equals to R naught A raised to 1 by 3, and R naught 1.2, mass is 64 raised to 1 by 3, that is 8. You'll get the answer, that is 4.8 Fermi. In the OR part, a proton and an electron have equal speeds. Find the ratio of de Broglie wavelengths associated with them. So we know that de Broglie wavelength equals to h by p. P is what? Momentum. Momentum is mv. On putting values of these, we get this as 1837. Okay, so that's it for section 1. I'll be uploading part 2 soon, today itself.